We are going to move right into our next panel, which is the Big Data Challenge, Capabilities Needed for Success. And our moderator today is Chitra Sivanadam. She is Chief Technology Officer for Reinventing Geospatial, otherwise known as RGI. In this capacity, she oversees RGI's data science, AI/ML, and cyber situational awareness, and understanding vision, strategy, and direction. Previously, she served in executive-level technology capacities at SAIC, Raytheon, Exelis, and In-Q-Tel. Please welcome Chitra and the next panel.
All right, thank you for that introduction, John. And I really appreciate being able to moderate this panel. I think this one should hopefully be a fun one. A slight change from what you guys see in your leaflets. So let me do the introductions real quick. So we have John Beieler from
Close enough.
Director of S&T from ODNI. In this role, John identifies and synthesizes technology trends to guide the IC in our science and technology investments. Prior to ODNI, he was a former IARPA PM, and as well was a renowned researcher and data scientist before.
Renowned is a very strong word for what I was, but
I thought it was pretty renowned. Next, we have Heather Martin, Deputy Director for Plans, Programs, and Strategy in Data and Digital Innovation at NGA. In that capacity, she assists with setting the strategic vision for our AI and data acceleration efforts for NGA and the greater Geoint community. She has an extensive background with the U.S. Air Force and the NRO, with a range of expertise ranging from cyber to counterterrorism to Geoint. And Kate Zimmerman, representing our industry partners from Hawkeye 360. In her role, she applies machine learning and AI to maximize value from Hawkeye 360's large-scale geospatial data sets. She also brings to bear good private and public expertise in both her roles supporting the U.S. Air Force as well as in her industry experience at AWS. I do really appreciate the discussions we had with the previous panels. And they laid out the current thinking for our AI strategic efforts, ranging from C2E to the JCF. And we talked about some operational kind of outcome-focused initiatives and how we think about AI strategies in that outcome-oriented perspective. In this panel, we want to kind of take a more future-oriented discussion around capabilities and, what do we have, where are our gaps, what do we need to think about. The National Security Council for AI, it was about a year ago that they published their final report. And the way they talked about it, they were looking at the technologies we need to have in place by 2025 to beat this critical race against China. I think some of that was brought up in the previous panel as well. So we want to kind of discuss how we think about capabilities and how we think about generally like AI readiness in preparation and trying to meet those 2025 goals and objectives. So with that, maybe I'm going to ask John to take the first question. So looking kind of at our foundational enterprise readiness goals, how do you think about the infrastructure we have in place and what we can do in terms of that enterprise readiness and the enterprise support to be able to develop and utilize AI?
yeah, definitely thank you, and thanks to INTA for setting this up and providing me the opportunity to chat with y'all today. I'm sure you're all disappointed you didn't get to see David as the pamphlet outlined, so instead you get me. We had to swap speaking events. But yeah, on where we're going in terms of digital foundation, as we refer to it, and making sure that we put the aspects in place to enable the mission of folks, because that's really what we do at ODNI. Right, we're not an operational agency, to kind of what Catherine was talking about from my ARPA standpoint. We're not building the widgets and deploying them ourselves. We're making sure that we are putting in place the policies, the guidance, the foundational technologies needed so that the mission agencies can get out there and go forth and do great things. So what we're looking at is largely working with, I see Phil and I see Nancy, our CDO colleagues, working with the IC CDO, working with the IC CIO. I like to say that we in the S&T realm are the squeaky wheel, right? So we're trying to surface up to these broader conversations happening around cloud and data and things like that and say, hey, here's what we need from a foundational standpoint to enable AI and machine learning. So that's really what we're looking at from our side. And then we'll speak more to this hopefully in some of the future questions and conversation, which is, the other thing that we tend to point out is that computers are hard, but people are impossible, right? So it's not really the tech problem that we're facing. It is the cultural problems of scaling and deploying these things. It is changing the tradecraft of the IC, because tradecraft is really fundamental to our DNA. So it's less the tools and how the people use them and how we push forward. So there's a lot there, and happy to dive into more of that.
Well, I think you have a good segue now for Heather as a mission component to address how she's utilizing what you're doing, getting prepared for that cultural and technological.
Yeah, good question. So I have a few different things I want to talk about, but I kind of want to revisit something that was talked about in one of the earlier panels, and I think it's actually been mentioned, and probably all the speakers have mentioned it so far. Foundationally, there's a lot of things we have to do to get ready to adopt AI, but I think one of the foundational things we have to do is really prepare our workforce for this transition. So some are really ready to get on board with this, others are not. So for us, foundationally, it's preparing the workforce, and that's kind of a range of things. So educating the workforce on what AI is and what it is not, making sure everyone has kind of that common lexicon that was mentioned many times today. It seems very simple, but even in a room full of data scientists last week, there was disagreement on how we define computer vision and machine learning. I mean, these are basic terms, but different organizations, even within NGA, explain them differently. So kind of level setting the workforce on AI basics, AI lingo, terminology. Another thing that's really important for us is identifying that talent that we need to bring into NGA to be able to do what we need to do and to work with our mission partners on AI. And then find really creative ways to not just incentivize them to come work with us, but to keep them. It's really hard to keep data scientists. They're hard to find, and when you get really good ones, it's hard to keep them. So that's kind of, again, kind of the basic foundation I think that we're really focused on. In addition to that, there's a few other things that we're working in NGA. So one is kind of getting our data house in order. So really creating, managing, and then securely being able to share trusted data. Jim McCool mentioned this earlier and said we have to be able to do this at the speed of our customers, though, right? They have very short timelines, so we have to make sure we can do that really well. I would say as part of that, we have to be able to make sure that the data that we have, capabilities we have, that we're making those discoverable, but they're intuitively discoverable. So I'll just take a little sidebar here. So I have teenagers, I have teenage gamers. Does anyone have teenage gamers in the room, right? So, when they go play Fortnite, there's not a 30-page user manual to tell them how to navigate the game and how to link up with other kids online, right? It's all intuitive. The tool is intuitive. So when you think these teenagers of today, in 5-10 years, they are going to be the war fighters, they're going to be the intelligence analysts. So they demand that these tools that we give them and how they find data and discover data, that it's intuitive, that it's easy. Army analyst told me last week, if I have to go past 3 clicks to get to the data, to get to whatever it is that you're trying to get me to use, you've lost me. So I think making things intuitive when we talk about data and discoverability in AI is really important. And then this was mentioned also earlier, the enterprise services. So we're really focused on whatever enterprise services are out there, leveraging those, not recreating things, so that we have that interoperability across the agency and across the IC.
Yeah, so I think definitely, I think the intuitivity and the access to everything is definitely fundamental. And I would like to know, Kate, from what you've seen on the industry side, how do you guys think about that? Because this is a data readiness, right? So there's data readiness that prepares you for how well the enterprise can function, that prepares you to this, ambiguous AI readiness that we all talk about, right? That has probably 1,000 different definitions. So how do you guys look at your data strategies and your kind of data enterprise readiness to support scalable AI?
Yeah, so if I'm familiar, so Hawkeye 360, we operate a constellation of satellites that collect commercial RF data. First day on the job, I come into the room, sit down at the table with my data science team, and we're like, what are the cool things we're gonna, apply this data to? What are the use cases that we want to solve? And kind of brainstorm, have a big long list of unique things that we wanted to do. Everything from pattern of life analysis, so as we see things change in the RF spectrum, can that tell us information about what's happening in the world? Looking at data fusion, could we take RF data, fuse it with imagery, fuse it with open source data to find new insights through those means? And so we had lots of cool ideas, but before we could actually build anything, step number one was making sure we had the infrastructure in place to support that journey. And we quickly found that in the past there have been quite a few analytic projects that have taken place in the company, and they showed some really cool results, and then they ended up on a shelf or in a report. So it's really challenging, even in a smaller company like Hawkeye, to get something from a cool idea, a prototype, to an actual production algorithm. There's a lot of steps that have to happen kind of in between. So our foundational capability that we had to build before we could even start working on those cool use cases or algorithms was actually what we called a machine learning ops pipeline. So ML ops, I'm sure most people have heard that acronym before, but what it's doing is it's taking the best practices of model development and fusing that with the best practices of software deployment through a technique called DevOps. And you put those together and you get yourself ML ops. And the whole idea is that we're going to have a standardized environment for building all of our machine learning models. So all of our data scientists are working off of a common platform. They have the same security controls that are implemented, access controls over what data they can access in our archives, being able to access the right infrastructure like GPUs whenever they do large-scale model training, having mechanisms to control cost so that whenever they go off and train big algorithms, you make sure that they're not just going off and doing their thing, and our costs one day, our bills, 4x what it was last month. So we've been implementing all of those controls on the developer environment, but I think just as important is actually the deployment environment. So we then had to stand up our container infrastructure, so how we were going to package our models into a standardized way, what toolkits we were going to install so that we can monitor those models once they make it out into production. And we also had to build our testing pipelines so that once we have our model built, how will we test it in an automated, scalable way. So this took a time hit. I think the data scientists were a little frustrated. They wanted to go off and start doing cool data science, but ultimately we didn't want our things to end up on a shelf. We wanted to kind of break that cycle and really stand up this architecture that would allow us to go end to end. And so that was really the foundations. So that took us a couple of months to really get the first, I'll call it beta out. The best plan rarely survives first contact, so once we started getting our first couple models through the pipeline, we had to iterate and change a little bit and be flexible there. But now we have 3-4 models that we should be able to get out in the next few months, and I have confidence that those will get to production because we're using an improved standardized pipeline that security's reviewed, that our IT guys have reviewed, and it's no longer this mysterious how will the model be deployed. It's just when will the model be ready. So that was, I think, the big foundational thing for us.
So it looks like you guys are all talking about enablers, right? So we have a lot of groundwork to do to kind of get ourselves ready to use the data that we've been collecting and to be able to produce this AI machine learning paradigm that we're talking about. So how does this work in terms of like the responsibility of the private industry partner versus the public government entity? You guys we're all working through different pieces, but there's still a lot lacking in that overall infrastructure. What is the government doing in terms of kind of bridging that gap, and how much do we have to expect industry to kind of do to be ready to produce what we need for the government? I'll throw it over to John first.
Sure. So what's the government trying to do? Be better, I think, is the general point. So a few things. We're trying to lay in standards in terms of models, data, APIs, and things like that. And ATO process, security, all those things, so that we can publish those out to industry and say, hey, if you want to insert a model that you have into one of our pipelines, here's the API standards that you need to adhere to. Here's how you access data. And again, make those public so you can build to those. And the like pie in the sky dream is, hey, if you build to this, if you use this certain container spec, if you do these certain things to the ML ops framework, things like that, we can say, okay, and no, I'm on a recording somewhere, but I was going to say, don't quote me on this, but could we get something like ATO in a day, ATO in a week, something like that? Yes, and everyone smiles at ATO in a day. But something not 18 months of an ATO process, so we can actually bring these things up Highside and apply them to our classified mission problems. Because I think everyone in this room has at some point done the thing where you work on the totally unclassified problem and then you try to get it applied to the mission set and everything falls apart. So we're trying to make that transition not happen that way, through, again, standardizing these things and then publishing them out and then enforcing those standards across the IC to say, hey, here's how we build things cross-agency, so that if, you know, there's a model at NGA, that it can transfer to CIA and vice versa, so that, again, we can kind of build once and apply widely.
Is there a notion, do you think, in the future where maybe instead of focusing on this transition from low to high, we just do a ton more on the low side?
I think that is very much the case, right? And open source intelligence, publicly available information, things like that are very much of interest. But at the end of the day, and this is a little bit to Catherine's talk earlier, we do have problem sets that definitionally other people don't have. So we need to figure out how to leverage what's good on the kind of low side, on the open source side, but not neglect the things that we do that are unique to our mission and our problem set.
No, I definitely agree. And I would say on the NGA side, you guys have already been doing quite a bit on the low side and trying to figure out how to use more public infrastructure, even open source to the extent you can. Like, how are you guys looking at where infrastructure migrates in the future to support your needs?
Yeah, thank you. So I would say a very similar approach to what my colleague explained. So we are really engaging with both industry and academia and trying to be really transparent about what our architecture looks like, what we're working on, what our hard problems really are, so that one, industry kind of knows what, not so much where we're going immediately, but even long-term, kind of looking at that 5-10 years from now. I think someone earlier mentioned this, 300% increase in Geoint that's coming our way. We're looking at that, thinking about what are all the things we need to get ready, what are the modifications or enhancements that we have to make to our existing architecture to be able to handle that huge influx of data. And we're trying to, again, communicate that to our industry partners and be really transparent about that. So they're ready along with us for that ride. And then kind of collaboratively also, not just telling industry what our problems are, but then really doing some engagements of, you'll hear, I think, in different forums, the accelerator program. I know someone mentioned InQtel earlier, so we're certainly involved in that. But at NG, we have an accelerator program that's kind of nested under Moonshot Labs, if you've heard of that. It's out in St. Louis, part of our Geoint ecosystem out there. And that is really communicating to our industry partners what our problems are, allowing them a space to kind of work on some of these problems, and then come back to us, prototype or outbrief kind of what they think we can do to solve some of these problems together. So that's kind of how we're engaging, being transparent, and then also finding that space to work together on some of these problems.
So there's been a lot of good discussion, I think, in the previous panels as well on how all of this fits into our definition of scalability. So how are you guys looking from a Hawkeye perspective at how you, like, as your constellation grows, how your infrastructure grows, so that you don't keep getting into that prototype to operational use kind of capability? Like, are there things that you're doing now to make sure that you're ready for the scale that you're going to have in the future?
Yeah, so I think this is an interesting question. So I've heard the term scalability discussed in terms of scaling of like number of models. But I will say for me, when I think about it, I'm thinking much more along terms of scaling the breadth of what we're doing inference against. So the way that I like to think about scalability is if we build a machine learning model, maybe it's focused on a limited use case in the Mediterranean Sea. How do we scale that out to other use cases, to other regions around the world, to other vessels? Can we reuse that core infrastructure and apply that to other use cases and problems? And so that's kind of how I like to think about it. And along those lines, I guess it's sort of like quality instead of quantity. How do we get a few really high quality models instead of just lots of different ones that are out there? And for me, that's really been thinking through the testing strategy and being open to failure. So whenever we are deploying new machine learning models, they go first to a very small region, very focused use case. We do live testing with end users to get feedback. And it can be pretty harsh sometimes, but that's okay, because then we add that into our testing and we can iterate on our pipeline and improve that. And we kind of slowly roll out in a very controlled way to scale that algorithm out across the world. And then the idea is that once we have that algorithm kind of scaled out, we figured out the testing, we figured out the bugs, we have a more robust testing pipeline, so that as we need to push out future updates of that model, it should be faster. Theoretically, we should find less bugs over time and be able to have a lot more global reach and impact from those models kind of as we grow. As far as scaling just the number of models, I mean, that's where the cloud comes in, right? So we can the pipeline scales, it's all in cloud infrastructure. If we need to test more models, that's all kind of baked in. So that's, I think, less of the concern for me scaling kind of horizontally with more models. It's how do we get the models that we have to be able to perform against kind of the whole area that we need. That is, in my mind, the bigger challenge.
No, I like that. I like that notion. So then it's a matter of like now we're going to have more and more models that can do lots of discrete things. I think somebody said earlier, it's a collection of a lot of little things that are likely to have the biggest outcome. So how do we then take this collection of little things that have been developed and actually turn them into things that solve like tomorrow's problems, and what does that experimentation and business transformation process look like? So either one of you guys.
Yeah, can I jump in first?
Of course.
Okay. I wanted to talk about governance in the last question, so this is a good opportunity to do it. So, we have so many people in the community that are trying to solve, these big data problems and AI, and everyone has their own, sandbox, toolbox, everyone's doing different levels of development. So something we've really been looking at NGA is how do we, and this current crisis, Russia-Ukraine crisis is kind of a perfect example, and I think has really forced us to do a little bit of this sooner than we had anticipated. But how do we in the community that are doing AI quickly come together to learn what each other's working on, who owns what models, how good they are, and then how do we serve that up to whatever the warfighter is at that point, right? If it's UCOM or whoever, how do we serve that up to the customer really quickly so they know exactly what exists, how good it is, they can kind of do a triage of this model over this model, and how do they get to that, right? And we have all these forums across the IC where we are sharing information on this and we're working together, but it's almost not enough, and people are so busy just developing these things that it's really hard to kind of take a pause and come a level up and say, okay, let's get in a room, who's got what, and how can we host it in one place so that the customer and everyone else in the community can get to it really quickly. So you think this would be simple, it's not. It's really complicated, it's hard to do these things because we are all operating in different environments. We all train models differently, and et cetera. So one thing that we have been working on at NGA is developing a Geoinside AI algorithm governance framework. Cindy Liu of our office, Data and Digital Innovation, has done some really fabulous work over the last year of developing this framework, repeatable process with tools where anyone in the NSG that's working, Geoinside AI algorithm can bring it to this process, and there's a board that looks at it, validates it, and then it gets put into a tool where folks in the community can go to that tool and say, oh, okay, here's what exists. Oh, and this board has certified it, and here's how I get to it. So it's a new process. We're wringing it out. We've gotten some different partners across the IC, so not just NGA, but other mission partners to bring their algorithms so we can kind of test drive the process. And it's growing, and kind of the next piece of that will also to kind of add some tests, some IV&D, some test and validation. So we're really working on some governance and standards so that as a community we can play together, especially in times like this where you've got a crisis pop up and you have to quickly kind of assemble everyone and figure out how you're going to tackle a problem together in a certain part of the world.
So yeah, go ahead.
I was going to say if I could kind of quickly pivot off of those two, because I think this governance question is fundamental to scale too, right? Because part of how we scale is through, especially in our world, through this automation of the governance, right? So like how do we do things like model cards for AI or data cards or things like that so that we can do those automatically so that we don't have to kind of bring the group of 50 nerds together to say, all right, what's everyone have? Right, because again, that doesn't meet speed, right? And that's another way that we scale up is through the automation of a lot of these processes and things like that. The other thing to call out is we have our IC ethical principles on like the ethical development and deployment of AI, and we're also looking at how do you automate some joints of that process to say so it's not a hand jam process for every analyst or machine learning researcher that wants to build something and deploy it again to hit this speed of mission to hit this scale.
No, I like that. And so if I go back to one of the things that Brian said in the previous panel about how we need to think about China, right? Our adversary that set off this whole journey, and I think that contributed largely to the National Security AI report, had to do with how do we keep our competitive advantage? How do we stay ahead of this? How do we not lose ground? So if we think about that and we think about data strategies and differences in our strategies, it seems to me that the fundamental difference is they don't have limits on how they think about collection and how they can serve data and to what use they can make of the data, right? So we follow lots of other provisions, appropriately so, to protect the US citizen. How do we compete fairly in that world where there is a disparity in how we think about our data governance, our data strategies, our infrastructure to support the IC? I guess
looking at me for the easy one, right?
The official one.
Yeah. How do we compete against autocracies? Great. Do we have another hour for the panel after this?
That'll be the post-drink session.
Yes, exactly. So what I'll say on the open, again, kind of leaning back on the ethical principles that we published, right? I think a lot of our strength in the intelligence community and America writ large is our values, is our principles, and our things like that. And I admit to being a bit of a heretic on these topics because I don't think that competition is as big of an issue, right? Because how many of these panels do you come to, and the thing that you hear from every IC analyst or researcher is, we have too much data, right? So I don't know that the problem is necessarily like the data. So to kind of slightly pivot off that question, I think really what we need to look at is, from my viewpoint, right now we're looking at how we deploy AI across the TC-PED process, right? Tasking, collection, processing, exploitation, dissemination. And we're layering AI on what has been essentially the same process since the 80s in many ways, right? So rather than looking at how we speed up individual joints of that TC-PED process, from my seat, we instead need to look at how should tradecraft look given the tools that we know we can build, rather than what tools can we build to tradecraft. And I think that's how we accelerate. That's how we win the strategic competition, is not kind of accelerating what we've done before, but figuring out what the world should look like, envisioning that future, and then building things in partnership with industry and academia and others to get to that endpoint. So I worry less about the data than maybe in a CAI did, but yeah, I'm just a guy.
No, I like that answer. So that actually is like a perfect lead into this thing I was thinking for a while. So recently, like by recently, like over the last 10 years or so, right, we've seen lots of evidence of like legit AI doing really good things, right? So we think of like that AI that beat humans at chess. There was recently this whole thing. I think Sony did it. The AI that beat people in Gran Turismo, right? And even more recently, AI designing chips, right? So computer chips. And we're seeing this advancement in this other sector of AI that looks different than some of the AI we were discussing before, but probably requires something different, right? So there seems to be like two different buckets of the type of things we're building. The thing that is predictable, manageable, probably something that we can audit, that we can think about the ethics, we can think about the logic that it's employing. I can interrogate the loops. I can think about the black box strategy versus the source code. But there's this whole other sector of AI that's doing remarkable things, that is really moving towards this human-inspired, nonlinear, likely unpredictable strategy. And how do we foster that? And what capabilities do we need in order to build that thing that's less predictable, that might be tougher on the ethics question, might be tougher on how we think about predictability, and might actually require us to rethink the TC-PED workflow or all of our IC functions?
So I'll take a quick crack at that. So I think in general, as far as how do we move faster and adopt these really innovative technologies that maybe put us out of our comfort zone? As mentioned earlier, government doesn't move very fast, right? So one thing I think we really have to focus on is getting more comfortable with Agile and that whole fail early and often approach of learning by doing. We talk about this a lot in the government, but it's really hard to change a culture to adopt that strategy, right? Like everyone wants to move faster and do Agile development, and it's the cool thing to say I do Agile, but doing it really well is different than just saying you're going to do it or planning to do it. There's a lot of work that goes into it, and you have to be comfortable with not having, for those that don't come from Agile world, you have to be comfortable going in and not knowing all of the requirements, right? Basic requirements, and you're going to sit with the user or the warfighter, and they're going to tell you what they need out of the tool. You're going to let them play with it every spin or increment, and you're going to get feedback, and you're going to keep making it better, but you might not know what at the front end exactly what they need, right? They're going to tell you along the way. So getting, we said earlier, we're going to talk culture, but it really is for us in the government, I think, a culture thing of getting more comfortable with that kind of a development approach and seeing the value of that. And then also really seeking out, so being smart on the rapid acquisition pathways. No one has time to build a capability that in 5 years is going to be antiquated and not helpful to the warfighter, right? So again, just culture-wise, really getting folks comfortable with that idea of rapid acquisition. Yes, you will fail early and often, and that's how we make this model, this tool, whatever it is we're developing for the warfighter better. And then I think to your point, really making sure you always have that analyst or warfighter feedback with you embedded in that team to constantly be giving you that feedback, because as I mentioned earlier, those teenagers I mentioned, those gamers of today, those are going to be the ones that are doing the intel analysis. So we have to be able to build the tools and the infrastructure, not just for our analysts of today, but we have to kind of think forward in 5, 8 years, what are the demands that those analysts are going to be putting on us, right? They don't put up with systems that are glitchy now or these delays. They certainly aren't going to put up with it 5 years from now, right? So.
And I guess to that point then, Kate, I'm going to ask you, have you seen commercial best practices kind of encourage more transformative thinking as opposed to incremental development, so that we could figure out how do we adopt those things that you're seeing on the commercial side?
Yeah, so the story I like to tell here, I think, actually draws from my Amazon days, so call it to the Amazon guys back in the corner. So Amazon Go, if you haven't been there, it's like a grocery store. It's kind of like a fancy 7-Eleven. It's got way better food and stuff, but you don't check out. So you walk in, you scan your phone, you pick up the stuff off of the shelves, you put it in your bag, and you walk out. And then AI and all kinds of tracking tools inside the store are able to figure out what you picked up off the shelves, and it charges you it's correct. I've tried to cheat it a few times. It's always right. And what's crazy is that was an idea that was just like an off-the-wall idea. They had this annual exercise where they're just like, everybody submit your crazy ideas. We're going to go through these and rack and stack these ideas, and some of them will get some money, and you can stand up a team and go off and do this cool innovative project. And some of those ideas are really off the wall. But Amazon Go, that was in that pack of ideas. So they decided to fund it, and I think about the scientific endeavor that was. And it was absolutely a journey. I think they initially started down the path of facial recognition, quickly realized people aren't going to like that, so we have to scrap that idea. They don't want their faces on camera getting tracked. So then they had to come up with a new way to do it. So they ended up with this crazy gait analysis thing, and just some cool articles online that kind of walk through how you can see it's the height, the motion. They basically turn you into a little fake stick figure and have you walking around the store. But to get there was a lot of failures. There was a lot of lessons learned, and it took a long time. It wasn't a 1-2 year thing and now we had a prototype. We're talking 5, 6, 7 years before they really could even put their first store in. And even then, that store was very expensive. So then there was the question of, well, how do we make this a more cost-effective, scalable thing? So I think having that mindset of perseverance, and to your point, definitely accepting that you're going to fail. And there's definitely the contracting standpoint of are we spending our money well? But there's also the scientific standpoint of it kind of hurts when you have all this, you're invested in this great idea and you think that this is going to be the revolutionary idea, and you have to come to this acceptance that we need to try a new approach. So it definitely goes all over, on how you have to be perseverance, acceptance of failure, and you got to give those big ideas a chance, even if they're pretty off the wall. And you got to commit. It can't be a 1 year and then we're going to say it failed and scrap it and take it off the table. Some of these good ideas take time, and you have to know that, be comfortable with that, and be patient. So.
Very cool. So I've got a couple audience questions, so I'm going to go with them. So John, so it looks like cleaning data, curating data, working with unstructured data are all challenges related to big data and AI. What capabilities do you see that are in development that can address these needs?
Yeah, so I don't know if we can ever get to the point where we have a universal data cleaning and preparation pipeline again, because the applications in the community are so diverse and so bespoke in many ways. But for me, it's back to the boring point of making sure that the platforms and the kind of foundational aspects are in place, so that as these analysts come in, as the Fortnite gamers come in, they can actually turn on the tools that they need to do things for their individual applications. So again, I know it's the boring bureaucratic answer of ensuring the platforms are there, but I really think that's the critical kind of leg to this whole thing, is enabling that mission rather than trying to solve all missions with one universal application.
Yeah, I like that. I think it's about, and so it's always this continuum of looking to optimize over and over and over. Do you have any other perspectives on the Geoinside that are probably different?
No, I agree. I think it's easy, especially when we're all operating in fiscally constrained environments, whether we're Geoinside, whatever organization. So I think it's easy to get a little bit complacent sometimes when you're operating like that, but you constantly do have to continually kind of keep track of what you have and then what needs to be updated and make sure that you're keeping up with the infrastructure. So I think that's just something you have to keep an eye on, and also be able to really go argue for when those constraints are coming, and explain the importance of keeping up with that.
Now this question's for Kate. So explainability is critical for the government in general, and the IC in particular. Is that something that you are addressing in the private sector? Do your customers care how or why a model works?
That's a good question. What is it? The answer is it depends. We do a lot of work with governments, US government, but also internationally. So yes, a lot of our customers definitely still care about the explainability piece. Kind of back to the MLOps pipeline, that was something that I knew whenever we were building that this was going to be a thing that we had to think about. So we built in the hooks and the logging throughout the infrastructure so that should there be an error that we detect in a production model, we have the ability to go all the way back to who originally trained it, on what version of the data, when did they train it, what algorithm did they use. So you can kind of do that root cause analysis, but also so we can have that kind of provenance as the data moves through and it becomes a model. That said, I mean, there's still a lot of technical limitations to true, what people consider like AI explainability. There's only so much you can do whenever you use a neural network approach. There's definitely limitations to what we can explain there. So my approach has definitely been robust testing. It's how we'll handle that. We'll treat it as there would be bugs in software code. We will add test cases to our pipelines to scale that out. But the model is going to make mistakes, and we just have to have the right logging to catch those, so that when we do, we can do the root cause analysis and improve our testing strategy. But until the day comes where I can actually get a nice report that comes out of the model that explains why it's making certain choices, or at least a nice diagram or something, then I think that's how we're going to have to kind of tackle that challenge, because to limit ourselves to not using that technology because we can't fully explain it, I think would be doing ourselves a disservice.
No, that's an interesting response, and I think a perspective I have is that there's some large hedge funds that similarly are not exactly sure why their algorithms perform the way they do, but they're like, let's not break it because it's producing a lot of golden eggs, right? So you just leave it low, and I think that's part of the reinforcement strategy, right? If people get enough of whatever their perceived the high value outcome is, then they learn to trust more the thing, whether it's right or wrong. So it's an interesting dilemma related to, I think, some of the ethics and trust. So another question, and this is for Heather. As part of the Geoint AI governance framework, are you doing anything to share data across the Geoint community?
Yeah, great question. So yes, I'll say as part of that framework, there are members of that group that's developing that framework that are outside of NGA. So I won't list them all, but all the three-letter organizations, we have various folks, even members of our international partners, different mission partners are in there. So we are really trying to share what we're doing in that governance forum. Anything we're developing, we're trying to share that as well. We learned really quickly, again, that this is a lot harder than we thought. So not only are kind of the big three-letter organizations and then the IC doing this work, but now you have even the services and even a level down at the unit level. Some of you've got different units across the services are developing their own AI capabilities or investing in new capabilities. So really kind of wrapping your hands around and trying to just make sure we know, again, who's doing what, who's engaged in it, so we know who to go out to and invite to these forums. That has been a challenge in and of itself. But yes, we do reach out across the larger community, DoD and IC, to make sure we're sharing whatever it is we're developing. And that's certainly been the case with the recent crisis.
And I would say that I would assume that extends also not just within government, but within private industry, just like we're seeing with COVID and what we're seeing with Ukraine. There seems to be increased collaboration and sharing among partners and just industries at large, right?
Yeah,
Absolutely.
Yeah, and I was going to say, we on the commercial side, we have at NGA, we have a source commercial office, and they do probably daily engagement with our industry partners on the commercial side, and so they are They have commercial strategy. They are constantly engaged with our industry partners on the commercial side to make sure that we're sharing information, that we're being transparent. And with this current crisis as well, as you can imagine, every industry, academia, there's been a flood of requests and information of folks coming to us saying, how can we help? We have this tool, or we have this thing, or we have this idea, offering up their services. We have CRADAs, different research agreements with you. How can we work together to start solving some of these hard problems for the crisis that we're currently in, and then getting ready for whatever the next crisis might be too.
Yeah, so I like that a lot. And I think that a critical piece of that is we're looking at how we think about the data, how we think about the analytics, how we think about that overall collaboration framework. It seems to me that on all fronts, we're still very much focused on either the data or the models. Do we think that is still the itch that we'll be scratching in the future, or is there something else we need to look at investing in from a capability development perspective? What does that future paradigm look like? John, you're looking kind of funny. Someone for
That's situational. What I was thinking about is, because it's not about the data, it's not about the models, it's about the analyst. And I don't know exactly what the answer to your question is, but that's just, again, it's about how do we get the tools into the hands of the analysts that they need to answer these questions. And again, I don't know exactly what that looks like, but your normal analyst doesn't care about the data, right? Or like what model is running on the data. They care about, can I answer the question that's being asked of me? So figuring out how we kind of, again, push forward into the future and stop focusing so much on like, hey, here's the, plain spotting neural net or something like that, and instead figuring out what is this broader kind of strategic analytic question that we want to answer, and pushing towards that, I think, is the future.
Just to add on to that, so it's been a long time since I was an Intel analyst, but when I was a junior analyst, there wasn't a lot of trust in AI. It was a new kind of discussion. So we wanted to see all the data. If I'm gonna make an assessment on something, I have to see it with my own eyes. I don't want anyone touching it first. I would say kind of this next generation of analysts, they are the opposite. Hey, I don't want to see all that data. It's a huge amount of data. We know more is coming about what we have today. It's too much. Just give me the detections, or just tell me these things that I need to know in the data, but don't send the whole thing to me. Just email me something that says, hey, we saw activity at this place. So I do see this kind of change in this newer generation where they're okay with not seeing the whole thing, because it is so much more than what an analyst like me back when I was an Air Force analyst was dealing with. It's just so much data. So I think we're getting there slowly. It goes back to that education piece of making, helping our workforce understand the value of artificial intelligence and being comfortable with it, and knowing what it is and, again, what it isn't.
So I think right now, whenever we talk about like model, we're usually referring to 1, maybe 2. Larger systems might have like, maybe 10. That'd be pretty complex, I think, for a lot of different, agencies right now, having 10 models that are being orchestrated. But I see that continuing to grow, so that over time, AI is going to become less of just a 1 model type thing or a 2 model type thing, but more of like a system of systems type thing, where data flows through and gets routed to different models based on the question an analyst might be asking, or the type of data that's flowing in. And so I think that the large-scale orchestration of something like that is an area where we'll probably start to see technology grow. I know a lot of large commercial companies are already using this technology, but most of that's going to be their in-house proprietary blend of how they orchestrate that data. So I see that kind of growing as more of a hopefully open source trend to make things easier for us, but it still remains a challenge. And to add to that complexity, there's also the whole data orchestration as well. So when data comes into the source, how do you process it? How do you now flow it into this massive complex system of different models and algorithms? And I could see that really kind of exploding as we start to get more advanced algorithms built. So my nerdy answer to that question.
No, I like that. So whether I like it or not, I'm a systems engineer first, and then all this data science stuff second, I guess. So it's interesting, because I think it's a valuable approach to say, like, at some point in the future, you have models interacting with models, and there's data orchestration that happens to the benefit of the model or to the system, right? And it all ends up becoming a system interaction and towards some sort of outcome. I think it comes back to like an interesting question on how you trust the system, right? And how you think about that. And from a systems engineering perspective, it always came down to the interfaces, right? So then how do we think about the new world for AI when we start thinking about that analog of, interfaces in systems engineering design to like, what is that thing? It seems like to me that's an area that we haven't explored yet, but maybe there's a new thing that has to emerge in order to address this orchestration issue. John, I'm sorry, you as standards guy.
Yeah. So I think a couple things. So first, we're sponsoring with some of our UARC partners some human subjects research to look at what that interaction looks like, because it turns out we haven't done a ton of that in the IC, because doing HSR with IC analysts is actually really, really hard. So trying to figure out what those interfaces look like and I don't think like universally in industry or academia, the research literature, there's a great definition of what trust looks like in a machine learning interface standpoint, right? Like you trust your car because you know how it will react whenever you do a certain thing with the wheel and the gas, but what does that trust look like and that predictability look like? I think it's less about explainability and more about predictability, and like what does that actually look like? I'm not sure. So there's that. And then the other is kind of, Catherine mentioned the Better program. It has a fond place in my heart. It was my program at IARPA, looking at how we pivot from a kind of pull model of analyst search and retrieval, right? Like sitting down at an interface and banging out a Boolean query and getting information back, and instead more of a push recommender system isn't really the right word, but recommender system type, like, hey, we know you're an analyst, we know this is the desk you sit on, we know this is kind of the questions you're trying to ask. Here's all the relevant information to you, again, to this previous point about just show me the detections, right? So pivoting interfaces to be more, push rather than pull, I think is the other part of this kind of trust building paradigm.
And I like that you brought up recommendation systems and recommenders. So obviously we all probably think of our Amazon shopping cart as, the end all be all probably of the AI that we interact with on a daily basis, at least daily for most of us probably, more so in COVID than before. But how do we think about it? Like, the value there is Amazon knows what it wants to do. It wants me to buy more stuff. So when we are looking at the IC, we're saying, I don't know what tomorrow's question is going to be. How do we think about those things that are going to foster that equivalent value of AI when we don't know what tomorrow's challenge is, and how do we prepare for that?
Question.
Yeah.
I'd say the Amazon use case is a lot easier because they either buy it or they don't. So you have your ground truth right then and there, whether or not it was a good recommendation, right? If they put it in their cart, they buy it, if it was the right recommendation or not. The ICs, that's much more challenging.
Yeah, so I'm probably not going to answer this the intended way or based on what your question was, but I'll say, kind of going back to the trust piece, we've certainly, I'm sure you've seen on your end too, the threshold level for different analysts is different based on their mission. So we have, analysts that will tell us, talking about that kind of menu of CV capabilities that I mentioned earlier, and then some sort of a scorecard that tells you, how good it is and how many false positives and all that, so they can decide if they want to use it or not. We have some analysts in the community on the DoD side that'll say, hey, I know the scorecard says that's, that particular model is going to have a lot of false positives, but I'm actually okay with that because it's better than what I have now, which is nothing. It helps them in some way, right? Where, we have others on the other end of the spectrum that are really doing some detailed, pattern of life analysis, and they've been working projects for a very long time, and that algorithm, that model has to be precise, and so their threshold for that is much different. And so, certain models, there's just different thresholds based on, what their mission is and then how quickly they're moving. As mentioned earlier, there are some analysts that are willing to accept a little bit of risk, knowing they can kind of fill in the gap, based on their historical knowledge of a certain target area.
Right. This is a question for all of you guys. One of the most important capabilities needed for success is a skilled workforce. How do you view workforce recruitment, training, and retention challenges in your organization? And I'm sure it's been harder in the last year or two, right?
Can I go first?
Yeah.
Okay. I mentioned this a little bit earlier, but I was actually jealous. I think earlier in the earlier panel, one of the directors from the CIA had said, I have a huge cadre of data scientists. I got to find her later and figure out how she got that huge cadre. Because for NGA, it's really hard to find data scientists. So recruiting them, getting them in the door, As you know, anyone that works in the Intel community, there's a long lead time for clearances and all that, and you can lose a lot of really amazing talent just in that process. So obviously at NG, we're really looking at how we get folks in quicker. But data scientists, certainly that is a challenge, a recruiting challenge for us that we're really focused on right now. Engineers, data analysts, and then looking at, how do we incentivize them? So pay incentives, how do we incentivize them to stay long term? A lot of times, we've found that it's not always about the money. They really come here looking for those really hard problems that they can only do here in the government. So, we certainly spent a lot of time on, what is our recruiting strategy going to look like in the next, year or so that we really postured well to be able to do to do these hard AI problems that we're talking about.
And on the industry side, is it
It's
easier?
pretty much the same challenges that Heather just said. I mean, it's really, you need to have competitive pay. The market is pretty cutthroat for data scientists out there, kind of across the board. But the other big thing is definitely the interesting projects. A lot of people get into the field of data science because they see it as being very innovative, working with AI, working with this new cutting edge technology. So they're going to typically want to work on use cases that kind of follow that passion. So interesting projects is definitely key. In fact, when I go to recruiting events, I usually have a couple of cool ones kind of lined up. So when I talk to different candidates, I'm like, well, what we're working on are these neat things and those neat things, and see if their eyes light up and be like, all right, follow up with that person there. But it's definitely a key component to getting someone to stay for a long time too. I know that where I've seen the most attrition on my data science teams have been whenever a scientist gets stuck in one project for an extended amount of time. 1+ year, typically on the same project. It can get very monotonous. So having that kind of variety, I feel like, has helped higher retention by having kind of different projects every few months or so. And they could be similar domains, but just slightly different projects, because it can get very tiresome when you're fighting for that 0.25% improvement in your model's performance, and it's taking you months to get there. It can really kind of wear you down. So.
And do you guys see any challenges with the fact that a lot of times you, maybe a data scientist that got enamored with a particular mission set and a problem, and you spent 99% of your time cleaning some really crappy data before you get to do any data science? Is there anything we can do to alleviate some of the stress points to get people to want to come to the organization, or rethink the way we think about roles and how we prepare it, or use technology to enable a better experience for a data scientist?
I could speak, on the industry side, I know that, that's a very common challenge no matter where you go. I think enabling the data scientists to be able to actively participate in the restructuring of that data storage or helping create those data pipelines is really key. Because if that doesn't happen, what will happen is the engineers will build a solution that may or may not actually fix the problem, or it'll fix the problem for that one use case, but then they'll go do the next project and then we'll be right back where they started. So having a cohesive data strategy is key. If you're going to have a data science team, having them give their input to that data science strategy is also key, and having them be an active stakeholder as you build out that data storage architecture is also key to keep them engaged so they know that the change is coming, they understand why it might be slow, they're part of that process, so they don't get frustrated and say, you have bad data, I'm going to go somewhere else.
Okay, so pivoting a little bit for John. So what are your greatest capability needs if you had to pick one or two, and how can industry help?
Oh, what a perfect setup. So we recently released an RFI out on sam.gov for our InStep program, which has, I don't remember how many are unclassified, there's about 220 classified S&T needs that we have, and that document that's out on sam.gov lists out all those unclassified needs that we have, and we encourage people to read that document, take a look, and then send us, in response to that RFI, the capabilities that you can have to solve some of those S&T problems. And just to give a quick rundown of how we've done that, we go talk to our mission partners and basically say, what kind of collection and analysis gaps do you have? What sorts of questions can't you answer today? We translate that into, again, a technical need, right? Because usually it's infer leadership intentions or something like that, and that's not really a technical thing that we can get after. So again, we've published that out, and that's kind of the point of that RFI is to provide the front door out to industry so that you can get your capabilities in, because I know oftentimes it is hard to find like where at NGA, where at CIA, where at NSA, where's the place that I go to send some of this. So we're trying to do the ODNI thing and be that umbrella across so we can say, oh, NGA, here's this great capability that we got from the RFI, are you interested in that? And then kind of broker those intros and then get out of the way to let mission go. So again, sam.gov, I think we have some hard copies floating around maybe today. But again, if anyone has any questions, we can follow up after and I can point you in the right direction.
And just to put you on the spot, if you had to pick like one or two things that are like always in the back of your head in that long list of needs.
Yeah, how we triage data for analysts in this kind of AI ML space, but then kind of there's a category in there of like off the wall convergence things that we don't anticipate, right? Because that's one of the things that scares me the most about the AI application space is like using AI to shrink the search space for like synthetic biology or something, right? So it's like the unexpected off the wall application. So welcome things that we haven't thought of, I think is the answer.
And Heather, on the NGA side, do you guys have a like particular one or two hot buttons?
I think I've gone over most of
I
them
know.
today.
Besides the workforce transformation,
Yeah.
if there was a specific technology, I guess, point solution, if I don't want to say point solution, but
Yeah, I think we're dealing with the same thing. I mean, we have all this data. I want to be able to quickly, our analysts want to be able to quickly have access to all kinds of GeoInside data, and notionally be able to run a model. I know this is very challenging, but different kinds of data, right? We have all different kind of phenomenologies and sensors, but having something that can run on, multiple types of data pretty quickly, so that we're not looking at, we're not having to zoom through and find that one thing in several images that we care about. So it's not a new problem, right? But that I think is what trips us up most. And since you were mentioning RFIs, I don't have an RFI on the street, but something I just want to share with the industry partners. When I look at RFI responses, something I really love is when the industry will somewhere bake in their response a reminder of here's all the things we're currently doing with you and with who. Because I am in data and digital innovation, but our research counterparts down the hall maybe have a CRADA with different industry partners, or maybe doing different types of work that I'm not privy to. So it helps make all of our jobs easier, of course, if we have that kind of laundry list up front of here's the answer to your RFI, and by the way, here's a reminder of everything we're doing with you currently.
So here's a good question that it would be fun to kind of get the government perspective and the industry perspective. Have you had or have you seen any AI machine learning software been certified for use on an IC computer system, like actually on the Highside? And the follow-up to that is, in that process, for whatever you saw or whatever you had part involvement in, was it rapid enough? Or are we still like too early in our AI journey to really have accredited software out there?
So without going into a ton of details, since we are where we are, the answer is yes. Like we do have machine learning solutions to things in our mission environments. Was it fast enough? The answer is always no, right? Like unless it takes literally a day, it's not fast enough. But again, to the whole previous conversation, that is what we're driving towards and what we're building towards is how we can enable that foundation.
Yeah, so same thing. Last week, someone asked a very similar question, and my answer was for this particular capability they were asking about, I said, for this piece of the mission, yes, but for this over here, no. And the customers in the room and said, totally agree. Yeah, for certain things it's great, but for these over here, no. So it's, obviously we're learning.
And for Hawkeye, do you guys have accredited software on the Highside at all?
We do not.
Okay.
Data only. So I have not had the pleasure of doing a Highside accreditation yet, but I hear it's a lot of fun.
A lot of fun.
Yes.
Always a lot of fun. And I think we might have room time for like one more question. I'm gonna throw this funny one out there that I was like thinking about. So it made me chuckle when the metaverse and Second Life and everything was brought up earlier. I remember those days fondly thinking that all this stuff was near term, but maybe one day soon. But it made me think, like, sometimes these technologies that don't feel like there's an obvious connection to the mission set have these other underlying capabilities or underlying transformative needs that they're able to address, but we have to think about it differently, right? So in the case of some of those earlier technologies, I think they laid a good foundation for how we think about, bandwidth optimization and how we look at, multimodal use of capabilities, and how, especially for pixels, how we're working in large pixel-rich environments without, blowing our comms. So how do we really think about these type of capabilities that, may look like it's colored towards a certain objective, but at the end of the day, it really meets another objective, and how do we really encourage the development of it? Kind of, I think, along the themes that everyone discussed before about you might fail several times over, but, the failure is not really a failure. It might just be meeting another objective.
Sure. So I think hard problems are hard problems, and they're good, right? Like, I think we called too much stuff a moonshot, but we went to space and everyone got Tengen Velcro, right? So it's like doing that. So like trying to do hard things so that it has all these secondary and tertiary outcomes, right? So that I think to IARPA, to what Catherine was saying, like pushing those boundaries gets us lots of goodness that we might not anticipate. So again, it's kind of trying to envision this way far out future and then figure out whatever falls out of that.
Yeah, same kind of thing. I mean, I think, if you're investing in something and it may not turn out to meet a mission need here, but you can use it over here, communicating that clearly to those that kind of have the purse strings of, hey, this is actually really important and solves another problem over here. But then also, I think the government, we could do a better job of when things over here don't meet either, truly doing good business, return on investment. Okay, this is the time where we need to, to your point earlier, there's a point where you have to make a call and stop whatever it is you're doing if it truly isn't going anywhere, and then reinvest in, the next thing that you need to be focused on.
I don't know if this is too nerdy of an answer or not, but I'm going to go for it. So I know, like, working in RF, for machine learning in the RF data domain, there's not a lot of public open research about that. So what we end up doing is taking a lot of look at things that might have been built for computer vision use cases or speech use cases and natural language processing, and trying to figure out how we could adapt that to this data domain. So it's definitely been about keeping an open mind and reading a lot of white papers and having a lot of white paper discussion groups and saying, hey, like, if we try this against this data, like, could that work? And give it a try. What's nice is that once your data is in a pretty clean state, trying the different model algorithms is not quite as hard, at least. So that's kind of been our plan. Our strategy has been just kind of trying things as we see the state of the art and the different white papers out there. And sometimes it works, sometimes it's a spectacular failure, but that's part of the fun of science all the same. So that's been our, keep an open mind about, innovative ideas. So.
Very cool. And thank you all for joining me on this panel. I think the takeaway from the whole day, I think, has been this culture of experimentation, at least, is well on its way.
Chitra and panelists, thank you so much. Can we have a round of applause for them, please? And also, I would like to comment, there is a handout in back. It's from the ODNI, and it is about categorizing the IC's S&T needs by technology domains. So that's a one-pager. You can pick that up at our break, which is starting right now. We'll be back in 15 minutes for our final session, the fireside chat. Thank you.